Focal mechanism solutions. A focal mechanism or beach ball is a graphic sign that indicates the type of slip that occurs during an earthquake. Strike slip, normal, thrust or reverse, or some combination. It also shows the orientation of the fault that slipped. The focal mechanism describes the deformation in the source region that generates the seismic waves. Focal mechanisms are derived from a solution of the moment tensor of the earthquake, which itself is estimated by an analysis of observed seismic wave forms. It usually takes at least 10 records to produce a reasonable focal mechanism solution, and then only if the seismograph stations are well distributed geographically around the epicenter. The complete characterization of an earthquake's focal mechanism provides important information, including the origin time, epicenter location, focal depth, seismic moment, and the magnitude. And from the moment tensor, we can ultimately resolve the orientation and sense of slip of the fault. This wealth of information about an earthquake is simply of interest to a structural geologist working on an active structures. The moment tensor solution is typically displayed graphically using a so-called beach ball diagram. The pattern of energy radiate during an earthquake with a single direction of motion on a single fault plane may be modeled as a double couple, which is described mathematically as a special case of a second order tensor, similar to those of stress and strain, known as a moment tensor. The data of an earthquake is plotted using a lower hemisphere stereographic projection. The azimuth and takeoff angle are used to plot the position of an individual seismic record. Two possible focal mechanism solutions. Without additional information, every focal mechanism has two possible fault orientation. The strike slip example could be a left lateral fault, the one which is on the left side, or a right lateral fault, the one which is on the right side of the picture. Example of a focal mechanism for a normal fault, which is on the left side, and a thrust fault, which is on the right side of the picture. A sketch of the cross-section for the normal fault is under the focal mechanism representing the fault type on the left, and the cross-section for the thrust fault is under the focal mechanism representing that fault type on the right. Example of a focal mechanism with a horizontal strike slip component and a vertical component, normal or thrust. There are several programs available to prepare focal mechanism solutions. One of them is MATLAB. This software plots the first motion polarity data as it arrives at different stations. The compression and deviation are separated using mouse help. A final diagram is prepared automatically.